Hello everyone, welcome back to my channel Knowledge for You. Today I'm going to discuss the most important 5 mark questions. So already I have made few more questions related to part 3, that is 5 mark question. Please go through my previous videos. So let's start today's topic, that is working of 4-bit shift right register. This is also one of the important 5 mark question from part C, digital electronics subject, which is common to ECE, instrumentation branch, electrical branch and computer science branch. So see here, firstly see the definition of shift right register. A register which shifts the data towards right side. A register which shifts the data towards right side is known as shift right register. Since the question is 4-bit shift right register, therefore we have to use 4 flip-flops here. That to D flip-flops we have used here. And next this is the D0 flip-flop. First D0 input, D1 input, D2, D3, and the outputs are Q0, Q1, Q2 and Q3. The input data is given towards left side and the output is taken from the right side. Here each bit is shifting towards right side, therefore we are calling it as right shift register. So next you have to draw the truth table here. Truth table indicates how many clock pulses we are applying here. Initially, before applying any clock pulse, the D input D0. So let us consider that I am going to take the data 1011. Okay, I am taking the data 4-bit 1011. It should be stored and shifted in the register. So this is the first bit we have. Initially we have to consider that the output of every flip-flop is clear to 000. Okay, so you have to mention that initially the output of every flip-flop is reset. Therefore the overall output is 0000. So when the first clock pulse is applied, the input bit, that is the leftmost bit. So this is my given data, that is 1101. So this is my 4-bit data I am taking. In this one is LSB and this one is MSB. So 1101. This is the leftmost bit, nothing but least significant bit. First this bit we have to take and it should be applied as input to the flip-flop. That is 1. Okay, so this 1, whenever input is applied to the first flip-flop, then D0 is equals to 1 here. D0 is equals to 1. If D0 is 1, then the output Q0 is also 1, because output is equals to input here. Output is equals to input. Therefore this D1 bit, that is the D0 bit, it is going to forwarded as output of Q0, whereas the remaining outputs will be 000 only. Next, when the second clock pulse is applied, then the data, next bit of LSB is what? 0. Then this bit will be stored in the first flip-flop D0 and output is equals to input. Therefore, this 0 comes and occupy Q0 bit. And similarly, this 1 is shifted. This Q0 output is shifted to this flip-flop. Therefore, the Q1 is also becomes what? 1, and the remaining flip-flop's output will be 0 and 0. When the third clock pulse is applied, then the third bit is stored in the first flip-flop. Therefore, the output of Q0 will become what here? 1. And this 0 is shifted to the next flip-flop. This 1 is shifted to the next flip-flop, and here we get what? 0. And the last fourth clock pulse is applied, then the final MSB bit is applied at the input of the first flip-flop. Then output Q0 is equals to 1. This one is shifted to this flip-flop, and this output is shifted to this flip-flop. This output is shifted to the flip-flop. And this one comes and occupies Q1. This 0 comes here and this one comes here. And finally 1101 data is stored in the register. That means here we are storing, at the same time we are shifting the data towards right side. Therefore it is called as 4-bit shift register, shift right register. So do remember, first we have to write down the definition. A register which shifts the data towards right side is known as shift right register. Then draw the diagram, draw the truth table, and finally draw the timing diagram. First draw the clock pulses. Totally 4 clock pulses. We have 1 clock pulse, 2, 3 and 4. So here here it indicates from here to here is a 1 clock pulse, here to here second clock pulse, third clock pulse, and finally fourth clock pulse. So what is the input data we have taken here? 1101. 1101. Okay, so here we have what? It is what? 1 data. Okay, this is what? 1011. This is what? 1011. 1011. Okay, so take it as D in bit as 1. Next we have what? 0, and next we have what? 1 and 1. So this is what? 1 0 1 1. Okay, 1 0 1 1. For this 1011, what is the Q0 output status we have got? Q0 we have got 0 1 0 1 1. So for the first clock pulse we have what? 0, and for the next clock pulse we have what? 1. Next we have what? 0, and next we have what? 1 and 1. Next we have Q1. What is the Q1 status? First two zeros we have, then 101. Okay, so this is 0, this is 0. Next we have what? 1. Next we have what? 0. Next we have what? 1. Next we have Q2. What is the status of Q2? 3 zeros, 1 0. This is 0 0 0, and next 1 0, and finally Q3 we have what? 4 zeros and 1s. So 0 0 0 0, and finally it is 1. So this is the timing diagram of 4-bit shift right register, and you have to explain in simply by mentioning 4 points. That is, first, initially the register is clear to 0 0 0, and we have considering the 4 bit of data 1101, which is to be stored in register. So first we have to take the least significant bit. What is the least significant bit we have here? 1 is applied at the input of the leftmost flip-flop. Then at the falling edge of the clock pulse, the data bit at the D4 is sent to the output Q4. Okay, that means output is equals to input. So whatever the D4 value we have, the same is forwarded to Q4, and therefore the output we get 1000. Similarly, when the second clock pulse is applied, then the new bit, that is next bit we have what? 0 is applied at the first flip-flop, and then the output is equals to input, and the output of the first flip-flop act as input to the second one. Therefore at the end of the second clock pulse, the output is what? Here it comes 1, next 0 1 0 0. Similarly, when the third clock pulse is applied, again the next bit of the input is applied at the input of the flip-flop. It will be forwarded to the next flip-flop, and finally we get the output as 1 0 1 0. Like that you have to proceed for the 4 clock pulses, and at the end we get the final output as 1101. So this is the 4-bit shift right register, and if you get the question for 4-bit shift left register, simply what you have to do, you have to draw the same diagram, but here instead of writing the data input here, you have to mention data input on the right hand side, and here you have to mention the output. Okay, and you have to start instead of taking LSB bit, you have to start from MSB bit. This is the only difference you have to remember while writing the 4-bit shift left register. Next we have working of 4-bit bidirectional shift register. This is most important question for 5 marks. Here also we are taking 4 flip-flops, D flip-flops, and the only thing is here coming to the definition of this shift register is a flip-flop or a register which performs which acts like a shift right as well as shift left register is known as bidirectional shift register. A register which shifts the data, a register which shifts the data towards right side as well as left side is known as bidirectional shift register. So since it is performing dual role, therefore we have to take a control input, that is R by L bar. So this is the control input we have, R by L bar. So do remember how to draw the diagram. First take the AND gates, G1, 2 AND gates you have to draw. Here 2 and 2 AND gates. The output of these AND gates are connected to OR gates like this. Give the name of the AND gates like G1, G2, G3, G4, G5, G6, G7 and G8. And the output of OR gates are connected to the input of D flip-flop. Input of the D flip-flop. Next apply the clock input. Apply the clock input here to every flip-flop. Next, the output of the first flip-flop act as input to this D2. Similarly, this output act as input to G3. This output act as input to G4. And additionally, we have to connect a D input to the first AND gate, and this connection should be given to the last AND gate, that is G8. So this one you have to remember. D is given to the first one, it is given to the last one. Next we have R by L bar. This right shift connection is given to G1. Next this one G1, G2, G3, G4, and from this inverted output, there is a left signal should be given to what? G5, G6, G7, G8. Okay, so do remember this. For every gate you have to give two inputs. And coming to here, this is the last output we have. From this connection you have to give this output should be act as a here. Okay, this one should be given connection to G7, and here similarly this G4 from this QC connection should be given to G6. From this QB connection should be given to G5. So this completes your connection. So do remember this connection. So a register which shifts the data towards right as well as left side is known as bidirectional shift register. This one is important question for 1 mark. Accordingly, you have to proceed your answer. Yeah, here you have the two cases. Write on the first case shift right, and second case shift left. Right shift means when the control input R by L bar is equals to 1. When the control input R by L bar is equals to 1, it behaves like a right shift register. And next point you have to mention that in right shift register, gates G1, G2, G3, G4 are enabled, whereas G5, G6, G7, G8 are disabled. Therefore, this G1, the output of this G1, here you have the OR gate, then this G1 is applied to the D input via OR gate. Similarly, the output of G2 is applied as input to D gate via OR gate. Like that you have to proceed. Okay. So in this manner, it behaves like a right shift register. Similarly, case 2, shift to left register. When the control input, what is the control input we have? R by L bar is equals to 0. It behaves like a left shift register. And here which gates are enabled? G5, G6, G7, G8 are enabled, whereas G1, G2, G3, G4 are disabled. Okay. And the input is applied to this D flip-flop via OR gate. In that manner, it behaves like a shift to left register. So write these points, it will be enough. And next we have serial in parallel out shift register. Serial in means it needs 4 clock pulses to store 4 bits of data. So this is the diagram we have. Input, the output of this act as input to this, the output of this act as input to this, the output of this act as input to this. And these are the outputs we have directly. We are taking the connection Q3, Q2, Q1, Q0. And this is the clock input we have applied, which is the synchronous clock input. So do remember this diagram. Okay, so I'm going to end up this video till here only. In the next video I will explain serial in parallel out shift register is completed, parallel in serial out shift register I will be taken, and next apart from that part A questions from each unit I will carry out the session. Please like, share and subscribe my channel. Thank you.